doubt, let it be the first bit. That's the first topic, atomic structure. And now second topic, with your consent, with all we decided that let us start the periodic table studies. Again, is a part of paper 1. Paper 1, second bit I am discussing now, about which if you are in doubt, any question, feel free to ask.
No question, sir.
Good. See, it's the response. If no question, then also you have to say the no question so that clarity remains. It's a proper way of communication. Namrata, brilliant.
So I also don't have any question.
Yeah, okay.
No question, sir.
No question.
Good. Yes, Sridhar.
No questions.
No question, sir.
Jagruti.
No question.
Gopal.
No question, sir.
Manthan.
No question, sir.
Yes, do not allow me to ask. You have to say spontaneously. Yes, Jagruti.
Sir, I'm Shravani. I have one question.
Yes, Shravani.
Sir, please explain again radial distribution.
Radial distribution, about which I need to discuss. Okay, fine. Will you share where exactly the problem or nothing is clear or partly clear, but this portion is not clear? So suppose if you say that portion is not clear, then I could able to focus on that area, no?
Sir, actually
Yes.
partly clear.
Means up to where concepts are clear? Partly means
Sir, actually I don't have notes
difficult question.
now.
Now notes are not there. That's see, notes should not be there only for the writing purpose. They should not only in the books. I'm talking about concept. Word to word, I don't want the thing. If anything you know, then also you should know. And if you don't know, then at least that point you don't know. Maybe radial distribution for S orbital or P orbital, or S orbital is clear, but P orbital is not clear, about which I am asking. Okay, Jagruti, then tell me, which orbital radial distribution shall I discuss? S, P, D, anything, any out of the three, choose one. By which I will start discussion.
Shravani have the doubt.
Hi, Shravani, I think. Shravani was the question. Yes, which orbital, Shravani? Yes, I could not hear. Yes, Jagruti, what happened? No, I think connectivity issue is there. If you come in the connectivity, let me have the discussion. Yes, Fayaz, do you have any problem, any question? No, I could not hear. Is network issue from my side? No. Yes, Shravani, will you tell me exactly which orbital do you want? So what about others? I am audible to you, no? Means they are not audible. Shravani and Jagruti, they are not. Yes.
Yes. Sir, D orbital.
D orbital.
Audible, sir.
D or P?
D, sir.
Please repeat. D or P orbital. I could not hear.
D orbital, sir.
Okay. D orbital and its radial distribution I discuss. Yeah. I am presenting now. Could you able to see the screen that I am presenting?
Yes, sir.
Yes, sir.
Yeah. See, actually shell numbers are there. First shell, second shell, third shell, fourth shell, fifth shell, likewise. These are the main levels, shell number that we see. And within shells, within this main energy level, sub levels are there. Sub energy levels are there. And those are azimuthal quantum number. I want to know the answer from you. From which cell that D sub level will start?
So please ask again.
1, 2, 3, 4, likewise different shells are there. D sub level is a subshell. D subshell starts from which level, which shell?
3.
Right. 1D not there. 2D not there. But 3D is there. 4D of course will be there. So starting is done from 3D. So about radial distribution, I have to talk in case of the 3D orbital, say. Then how will that radial distribution can be represented? Just a bit. See, I represent the y-axis and the x-axis. So here is a nucleus. And I want to proceed away from the nucleus. So at the beginning, I'm talking about only the 3D orbital. So 3D orbital genesis at the beginning will not be there. As like for S orbital, so 1s orbital immediately is there, no? So here electrons will not be there. Its electron density will start after some distance. And near third shell, third region, you will find there is what the electron density. This is a representation for 3D. If I have to represent the 4D orbital, after 3D, the next orbital is the 4D. Then how that 4D orbital can be represented? 1D is not there, 2D is not there. So at the beginning, electron density will not be there. But near 3D, little portion of 4D will be there. Near 3D, little portion of 4D will be there. Are you following what I'm saying?
Yes, sir.
Yes, sir.
Okay. Afterwards, what region of 4D is there? Then again you will find what the 4D session. Actually here the node portion is there. So it will come down, it will meet to the y-axis. So 4D orbital, which is represented by the blue ink, start is there from 3D, but less electron density. But after all, again it is meeting to x-axis, this point where electron density 0. Now just answer for my question. If I find electron density is equal to 0, then to that what shall I say this portion?
Node.
It is called node, where electron density is 0. So this 4D orbital is with one node, and 3D orbital is with how many nodes? 3D orbital
0.
is with how many nodes? 0 node, because the beginning, first D orbital, 0 node. Likewise, first S orbital will remain 0 node. First P orbital, 0 node. From when S orbital starts, first S orbital will be, yes, which is first S orbital? I wrote already. First S orbital is, name that orbital.
K.
No, orbital. It's a 1s. First S is 1s. First P orbital.
1s.
First P sublevel.
2p.
Right. First D.
3d.
First F.
4f.
Yes. So wherever first sublevel is there, first type of that orbital is there, there will be no node. So genesis of higher orbital is there in the previous orbital. So 4D orbital, we need not to understand at only one level is there. Fourth shell is there. No, actually it starts from the 3D, as if like now you are the first year student, means in SRM college. After 2 years, you will be in the last year of graduation. Then you study at SRM college. So at that moment, you will be in the last year. You will be in the third year. You will at TY. But truly, in SRM college, your studies started from what? First year. So study point of view, when you will be at TY, you will mainly focus on TY studies, or mainly you will remember those TY studies. FY and SY to low level you will remember. FY less level, SY little more level, TY some more level you will remember. So electron density or function density or understanding density for third year, means after 2 years I am saying, will be more than SY, usually more than what the FY. Now you are at the first year. So whatever you have studied in the 5th standard, to less extent you might be remembering. Means memory point of view I'm saying. At 10th standard, what you have studied, little more extent. At 11th, little more. At 12th, little more extent. So because recently passed, no? So as like the distribution of your understanding of study remains, here we are talking about distribution of electrons. And the distribution with the respect to radius. Radius starts from nucleus. And from nucleus, as we go away, how will we find the electrons? That is the radial distribution. Shravani, are you following what I am saying?
Yes, sir.
Yes. So other students, the question asked by Shravani and whatever answer I provide, is it clear? This is about 3D orbital. Similarly, you work on P orbitals, S orbitals, and further if doubt comes, you can ask. Go through the videos. Previously, which are the posted videos are there, again go through the videos. And if still doubt remains, I am there to help you. I will not say how many times are you asking the question. No worry for that. Be free to ask the question. So other students, is it clear whatever I discussed now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes. So Shravani, had I answered your question
Yes,
or
sir.
you want further more explanation?
No, sir.
Okay, means I answered your question. Okay, any other question from any other student? Because few students have recently joined. No, see, in between few students are going. Why? For they don't have that good network connectivity. Therefore, I am providing the recorded lecture, and I expect you should complete the assignments. Okay, shall I move to the next point now?
Yes, sir.
Yes, sir.
Yes, sir.
Great. Now, next point I want to discuss in connection to the question asked by Shravani, and that point is radius. Radius of atom or ion. Will anybody inform me what's the plurality of it? Radius means singular. One atom radius. If many atoms are there or general things are there, then what we say instead of radius?
Radii.
Right. Radii. Radia. So atomic and ionic radia, about which I want to discuss today, and their periodic variation. I repeat, we are talking about atomic and ionic radia. Of course, atomic means related to atom and ionic means related to ion. Then what is the difference in atom and ion? Right, brilliant answer. These ions are gifted by charge. Charge. Which charge?
Positive and negative.
Right, it can be positive or it can be negative. Only two options are there. And atoms are there. Those remain with the charges within themselves. Protons have positive charge and electrons have negative charge, or charges you can say. But it is balanced. So atom as such is neutral in charge from outer point of view. But within that there are the charges. Ion inside also charges are there, and outer point of view also, experience point of view also, charges will be there. Why? When will there be positive charge? When will there be positive charge? Because repeat please, I could not hear. Okay, loss of electron. There are two things, no, because of which charges are there. One is proton, other is electron. So because of loss of electron, who are more? Protons are more, electrons are more.
Protons are more.
Yes, therefore there is a positive charge. When there will be negative charge, if
Electrons
electrons are more than that of the proton, means electrons are received by atom, electrons are accepted by atom. When there is positive charge, electrons are given. Now I need your help. Give me example of positive charge. That's an ion. One example. Any one positive ion.
Hydrogen plus 1.
H.
Okay. H plus. Any one negative ion.
Cl minus.
Right. Cl minus. Again, help me. In H plus, how many electrons are there?
1.
Yes, yes. Loudly. Whoever answered, no, loudly. Answer is correct. In H plus, 0 electrons are there. Listen carefully. Could you able to understand what I am saying?
Yes, sir.
In hydrogen, there is a 1 electron, but in H plus, there is what? The 0 electron. Okay, this tab is not writing. 0 electron. How many protons are there? H plus 1 proton is there, and therefore there is a positive charge. So H plus is the one ion where there is a no electron, only proton, only nucleus. Brilliant ion. Other ion you will not find. There were many times in chemistry, especially organic chemistry, when you study the reactions, then the H plus involvement remains to great extent, or special branch, special studies there. Acid-base chemistry means acid base. From OH point of view also we can discuss, means OH minus, but acidity in terms of H plus or pH concept. So that H plus, a very separate, different ion where there is a no any electron, or only one ion where only nucleus is there, only nucleus, only proton is there. But other example that I found, Cl minus. Answer for my question, in Cl minus, how many protons are there? Atomic number of chlorine, Z value.
17.
Yes. So in Cl minus, how many electrons are there? One negative charge. So one extra electron. So how many electrons will be there? 18. Yeah, one extra electron will be there. 18 electrons are there in the Cl minus. Extra electron gives negative charge to that ion. Here you will find protons. Here you will find neutrons. Here you will find electrons. But in H plus, generally, there will be only proton. But if you consider deuterium or tritium, heavy hydrogens, then for heaviness, something will be added, and that's a neutron. Yes, are you following what I'm saying?
Yes, sir.
Yes, sir.
Yeah.
Yes,
So I'm talking about atoms and ions. So basic concept about the atom and ion I told to you. Now let us think about the radius of atom or radius of ion, or in plurality, radia. So radius, basic meaning is same. If I consider a circle, atoms are spherical, 3-dimensional. Circle is a 2-dimensional representation. And at the center of the circle, there is a nucleus, protons. And outside there are what? The electrons. This distance, outermost electrons, or where there is a more probability of finding electron, because there is such a only one place where electron only will be there. Electron vicinity, electron nearby region. So therefore electron cloud that we say, and that's the most accepted model, electron cloud model. So wherever there is a more possibility, more abundance of electron, outermost electron, to that we say as a radius. If it is a case of atom, then we will say it is atomic radius. If it is a case of ion, then we will say ionic radius. I repeat, distance of outermost electron or electrons or electron cloud, majority of an electron from nucleus is radius. If I have to refine my answer, then it is a distance from center of the nucleus, this portion, center. 2, actually center of the electron, outermost electron. But electron is smaller, so we can consider up to electron. But nucleus can be larger, no? Nucleus can have the size up to 10⁻⁻14 meter. So it can have the center. From that center to outermost, that is called the radius. So broadly, whatever you consider the radius of circle, likewise radius of atom or radius of ion is considered. Base is ion or atoms are spherical in nature. Let the outer electron may be in any orbital, maybe p orbital. P orbital is not spherical, but even the atom will be the spherical if outer orbital is a p. S orbital is spherical, so there is no question about that. D orbital is not a spherical, but if outer electrons are in the d orbital, the atom or ion will be spherical. So about the atomic and ionic radii, just I told to you at the beginning about the charge means ions or neutral means atom. Second point I told about what the radius. Now I come to the third point, which is very important one. Third point, I am comparing the sizes with atom, sizes of ion with atom. If I consider a sodium atom and other formation is sodium ion. Yes, sodium ion means what should be charge on that?
Plus.
Plus. Means I am considering here cation. I want answer from you. Who is larger, Na or Na plus? Okay, let us consider you don't know the answer. I give you hint. Then you tell me. It is true Na plus is formed by loss of electron.
Yes.
Yeah. So in Na plus, number of protons are 11. I am talking about number of protons. And number of electrons are 10. In case of sodium, number of protons are 11. And number of electrons are, yes, help me. How many electrons are there in sodium atom? Neutral atom.
11.
11. Now imagine the thing. At center 11 protons are there and those 11 protons are attracting electrons. How many? 11. It is our case number 1. And case number 2, 11 protons are there inside and they're attracting relatively less electrons, 10 electrons. It is our case number 2. Where will be more attraction for electron? Which electrons will experience powerful inward force, powerful force towards nucleus? First case or second case?
Second case.
Yes, here will be the more power to attract the nucleus. So outermost electron, whoever will be there, that outermost electron will come towards nucleus or will go away from nucleus relative to case number 1. Towards nucleus or away from nucleus?
So please ask again.
Yeah, see, outermost electrons are both where? In sodium also and sodium ion also. Sodium neutral and cation also. But in cation, only 10 electrons are there. So in this, what is the 10th electron is there, outermost electron is there, that will come near to the nucleus or will go away from nucleus relative to, listen carefully, relative to sodium outermost electron. If there is a more inward force, if there is a more power of nucleus, then outermost electron is expected to approach towards nucleus. So because of that, answer the question now basically, which was that who will be the larger? That was the question. Sodium atom or sodium ion? Na or Na plus? Who will be the larger?
Na.
Na plus.
Na.
Na is larger. I think Vaibhav is answering Na plus. See, Na plus where electrons are less. So attracted powerfully. Powerful attraction is there. And because of that, electrons are coming inside towards nucleus. So overall size will what? Decrease. Size of the species, that's the ion Na plus, will decrease. So I want to teach you here one conclusion. Cations. Yes, what's happening? Just wait for it. Little issue is there in that writing pen. Yeah, this cations, again problem. Say I write here, cations are dash than atom. What's the conclusion? Cations are
Smaller.
right, smaller than atom. That only I wanted to teach you in up to here. Reason is because of more nuclear charge, because of more nuclear power, electron cloud will shrink. Why more nuclear power, nuclear charge? Because number of protons are more than electrons. Why number of protons are more than electrons? Because electrons are lost during formation of cation. Therefore, protons are more than electron. Now, reverse way. Since we remove electron to form a cation, number of electrons are less or number of protons are more. Due to more number of protons, nuclear charge or nuclear force remains high. Because of high nuclear force or charge, electrons get shrink. Electrons get more attracted towards nucleus. Therefore, size of cation remains smaller than neutral atom. Is this point clear?
Yes, sir.
Yes. Now I talk about the cation. Let us continue our discussion for anion. Example for anion, which was given there, Cl minus previously. So I write there for Cl atom and other Cl ion, chloride ion, Cl minus. Will anyone answer who will be the larger?
Cl minus is
Cl
larger.
minus.
Right, Cl minus is larger. Why? Stepwise, let us go. First point. In case of anion, I'm talking about now anion, number of protons and electrons. Yes, what happens? In case of anion, who is more, electron or proton?
Electrons.
Yes, it is the first point. Because of that, it has negative charge. Now, second point. Due to which effective nuclear charge or nuclear power will increase or decrease. Effective, resultant. Electrons are more. So effective nuclear power, I am saying.
Decrease.
Yes, will be?
Decrease.
Will decrease, will be less. Due to effective decrease in the nuclear power or nuclear charge, that species, which that species? Anion will be shrinked portion, shrinked section or shrinked aspect of atom or enlarged aspect of the atom. Anion will be expansion or shrinking.
Expansion.
Yes, it will be the expansion of the atom. Conclusion. What will be the conclusion? Anions are dash than atoms or atom. Yes, anions will be
Larger than it.
Larger than
large.
atoms.
Is this general conclusion clear?
Yes, sir.
Yes, sir. Yes,
You were
sir.
knowing this, but I want that you should go to visualization level and properly you have to cognize that thing. We are studying it further. Additional study we will do. It's just the basic, it is just the beginning. So in this point number 3, we have concluded two things. Cations are smaller than atom or atoms and anions are larger than the respective atoms. Now about two cations or two anions also we can have the comparison. Means if I say Fe plus 2 and okay, just wait here, little problem is there. Fe plus 2 and Fe plus 3. Among these two, means both are cations. Certainly those are smaller than atom. But among these two, ferrous and ferric, Fe plus 2 and Fe plus 3, who will be smaller? Ferrous or
Fe
ferric?
plus 3.
Fe+3.
Right. Yes. Means you are absolutely proper to apply the concept. More electrons are removed, so more nuclear charge and nuclear force will be there in case of this ferric ion. Therefore, its size will be smaller. Okay. It is about the relative charges among cations. About anions, yes. Will anybody help me? Two anions where are possible? As like ferrous and ferric, I told. In that way. Okay. Atom also, I consider molecular ion now. O2 oxygen molecule, O2 minus 2 peroxide, O2 minus superoxo. Among these two, peroxide and superoxo, consider O2 as one unit. Who will be larger?
O2 minus 2.
O2 2 minus.
Yes, O2 minus 2. Why? Because more burden of electron is there. Relatively power of nucleus or nuclei, molecular ion is there, no? Will be less. So because of that, expansion will be more. So 2 minus 2 will be the more larger. Means what you are doing? Simple logic. Cations are smaller than the atoms, or anion is larger than the atom. That simple logic you are applying to these ions or molecular ions. Is this point clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Now, fourth point
Yes,
I
sir.
want to, that is about the variation in periodic table. Fourth point I am discussing now. Variation of atomic or ionic radii in the periodic table. Both going in the same direction, therefore one time only I am discussing. Atomic radii is a one aspect or the one point and ionic radii is on the other point. If I talk about the group, say the first group. Actually, first group starts with hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium. Okay, here is a problem. Okay, on the writing pad, I could not write at that place. Okay, next, cesium, and last is francium. What do you think? Atomic size as I go from hydrogen to say last is francium will increase or decrease? Atomic size will in a group as I move from top to bottom.
Increase.
Yes. So in a group, that atomic size increases. Means as we move from top to bottom. That's a moment. It is a statement. Now I have to describe this statement, or I have to attribute this statement. I have to give the reason for this statement. We understood that size is because of the how effectively nucleus attracts the electron. More effectively attracts, shrinking will be there. Less effectively, expansion will be there. Now, if I have to talk about the atoms in a group, then hydrogen electron is present in the first period. That's the first shell, outermost electron. In lithium, electron is present in the second shell, second floor you can consider. In case of sodium, it is in third floor, third shell. For potassium, it is in the fourth. For rubidium, it is in the fifth. For cesium, it is the sixth. And for francium, it is in the seventh shell. So shell number is increasing. But by the way, power of nucleus also is increasing. So what is expected? All atoms should be of the same size. Means what? In case of hydrogen, there's a 1 proton, 1 electron. In case of lithium, there are 3 protons, 3 electrons. In case of sodium, there are 11 protons, 11 electrons. Likewise, we can continue. So same number of protons and electrons are there. Because of that, equal attraction should be there. Both should be of the same, or if electrons are more little extra, we can, but that is not so perfect imagination. Here, we need to consider one phenomenon. Just I give hint to you. And that phenomenon is called as S or S. One time one student asked the question, I described that also. Yes. S or S, what is that? Means only protons and
Shielding.
electrons. Yes, it is shielding or
Screening.
right, screening. That point we are not considering, or not, I had not considered in previous dialogues. Whichever electrons are there in between or nearby, they will shield or they will screen the other electrons, and due to which the net attraction will be less. Because of shielding or screening, the attraction will not be more, and because of that less in attraction, there will be help me, increase in size. Or yes, expansion will be there, right? And therefore this logic is that as we move from top to bottom, there is an increase in the atomic radius. Okay, so there's an increase in atomic radius. Same is the case for ionic radii. Reason is, see, I'm giving reason now, listen carefully. First reason is there is increase in shell number. Outermost shell number, there's increase. Second reason is, yes, help me, what is that?
Shielding or screening effect.
Right. Shielding or screening. And because of that, outermost electrons will experience, now it's a very conclusive point, that's the outer electron will experience relatively less power of nucleus. Means in francium or cesium, large number of electrons are there, but relatively last electron experience the less number of protons. In case of hydrogen, 1 electron, 1 proton, relatively that electron experience the more attraction. And the reason shell number is there, reason screening and shielding effect is there. Consequence is a relatively less attraction, and because of there's expansion or there is an increase in the size of the atoms or ions. So what is the statement? In periodic table, as we move from top to bottom in a group, a long group, as we move from top to bottom, atomic size or ionic size will increase. That is my fourth point of discussion. Is it clear?
Yes, sir.
Yes, sir.
Yeah. Now I want to talk about the last point for today's discussion with your help only, because you got the logic. How can we describe that? And that point is, in periodic table, if I move from left to right across period, how will the size vary? For example, if I talk about the second period starts from lithium, then is beryllium, then boron. Actually in periodic table, in between transition series elements are there. But in second period, those elements are not coming, so I am not representing. But in periodic table, there is a gap. Lithium, beryllium, after gap, there is what? Boron. but here I'm representing it continuously. Boron, then carbon, then nitrogen, then oxygen, then fluorine, and last is there neon. It is a period. So as I move from left to right across a period, that's atomic or ionic size. Yes, help me. What should be there?
Decrease.
Decreases.
Yes, decreases. Now we have to provide the reason for that. Why it decreases? Again, points will be the same. The first, the period number is same. Previously, period numbers were increasing. Shell number. Period number means I'm want to say shell number. All are in second shell. Here electrons are in 2s orbital. Here 2s orbital. Here electrons are in 2p orbitals. 2p orbitals. Anyhow, shell number is same. No, second shell. No, floor number is same. So shell number is same. Besides that, effective nuclear charge, effective nuclear power increases. Why? Because power of nucleus is due to charge. Power of nucleus is due to number of protons, and number of protons means atomic number. Here, in case of the lithium, 3 protons are there, and in case of neon, 10 protons are there. Timing, I keep that aside. Neon. I come to fluorine. Say 9 protons are there. Lithium 3 protons, and in case of fluorine 9 protons. But shell number is same. Electrons in that vicinity only. So because of extra power, because of extra charge, because of extra nuclear force, fluorine atom will be smaller. Therefore, conclusion is decrease. Because of increase in nuclear charge, effective nuclear charge, due to increase in number of protons, due to increase in atomic number, there will be the shrinking in the size as we move from left to right. Therefore, size what? Decreases. So what's the conclusion? Due to increase in effective nuclear charge, there will be shrinkage in the atom as we move from left to right. Therefore, size will decrease. Here, rough idea I had given. Particularly, I had not been. We are going in the next lecture. So students, today I told you beginning portion. That's a question of the Shravani about the radial distribution. Then I started new point, atomic and ionic radii. Basic concept about the atom and ion I told to you. That's a charge concept you only told. Positive charge, negative charge, cation and anion, that we understood. Then how the relation between the neutral atom and cation will be there. Then neutral atom and anion will be there. Then we went on discussing the periodic train. That's a variation. Along a group, how will size vary? Across a period, how the size will vary. That I discussed. So whatever I discussed, is it clear to all?
Yes, sir.
Yes, sir.
Yes, good. So student, shall we stop now?
Yes, sir.
Yes, sir.
Yes. Okay.
Yes, sir.
Stop the recording now. And I declare here today's session is over. Quit now. Let us discuss tomorrow.